Hey guys, happy Tuesday. So today we're going to be talking about something called reverse reverse. We're going to be taking, instead of looking at a equation and giving the name, we're going to be looking at a name and giving the equation. But first I'd like to show you a little something about bonds so we can work backwards from there. So let's say I have three C's, right? And let's say they are all connected by single bonds. So this would be an alkane, right? So every carbon has to have four bonds, right? So if every carbon has to have four bonds, then anything not involved with the big pieces is just going to be a little hydrogen bond. So this guy only has one bond right now. So I'm going to draw three little hydrogen bonds connected to him. So now he has four. One, two, three, four. This one has two carbon bonds. He needs two more. So I'm going to give him two hydrogen bonds. And this guy only has one carbon bond, so I'm going to give him three more hydrogen bonds. So now he has four. So the question becomes, how many carbons do I have? I have three carbons, and how many hydrogens do I have? I have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So that is my name. Okay? Now let's say we had something a little weirder, like, let's say this was an alkyne. Let's say this, we still have three carbons, but we have a triple bond here. Well, once again, every carbon has to have four bonds. So this guy has three bonds. He needs one more little hydrogen bond. This guy has one, two, three on this side and one on this side. He has four, so this one's happy. This one only has one, so I'm going to give him three more. So now all three carbons have four bonds. So how many carbons do I have? I still have three carbons. And how many hydrogens do I have? I have one, two, three, four hydrogens. So I have C3H4. So that's where these namings are coming from, okay? And it changes depending on if it's an alkane, an alkene, an alkyne, because depending on how many bonds you have here, it's going to completely change how many hydrogens you end up having. So let's talk about working this backwards. So the two things I'm going to be asking you to be able to practice today is identifying whether it's an alkane, alkene, or alkyne. I only see single bonds in this chain here, so this one would be an alkane. And I see a triple bond here, so this guy is automatically an alkyne. And then I would like you to be able to draw the structure. Now, there's only so many ways I can check your work on that on the internet, but you'll see in the homework how I'm going to structure it. So example number one, if I'm given C6H14, so already this is brutal. I'm starting it off with a big one, C6. So that means I have six carbons. And I don't know what the bonds look like on the inside of here. So I'm given nothing. But how many hydrogens am I supposed to have? 14. So let's see how many hydrogens would fit around the edges here. I could fit one here, 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 here. I could fit one here, 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 here. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can add two more. And if you look at how we did it here, you can have bonds on the end. So if I only need two more, I could put one here and I could put one here. And that would give me 14 hydrogens and 6 carbons. So if these are hydrogen bonds, if those are hydrogen bonds, then what would my bonds in between the carbons be? Well, they can only have four, right? This guy already has three, so he can only have a single bond added to that. This guy now has three, he can only have a single bond added. Now he has three, only a single bond. He has three, only a single. He has three, only a single. They all have four bonds now. So that's what it would look like. And since it's all single bonds, I know that this one is an alkane. Let me work another example. Let's say it gave me C2H4. A little more reasonable. So that means I have two carbons, right? And how many hydrogens am I supposed to fit around these two carbons? 4. Interesting. So I have to somehow fit 4 hydrogens around this carbons. So how many spots do I have available? I can have 1, 2, 3 here, and I can have 1, 2, 3 here. I have 6 spots for hydrogens, but I only need 4 of them. So if I only need 4 of them, I could put 2 on the left and 2 on the right. So let's say I did that. Let's say I put 2 on the left and 2 on the right. Well, if there's 2 here and 2 here, every carbon needs 4 bonds. So if there's 2 on the left, this carbon's going to need 2 bonds in the middle, so he has 4 altogether. And this carbon would need 2 in the middle, so he has 4 altogether. So since that balances out quite nicely, this could work as our answer. And if there's a double bond in there, that means it's going to be an alkene. So let me work one more example, and then I'll leave you guys to try some of these on your own. Alrighty, so if I have C4H2, my thought process is, okay, I have 4 carbons. So let's draw those out. And I only have spots for 2 hydrogens. I could put a hydrogen here, 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 here. I've got 10 spots for hydrogens, but I only have 2 that I can actually use. So something tells me that this is usually symmetrical. So I'm going to see if my hydrogens could just go on either end and see how that works out. So if I only have 2 hydrogens here, the rest of the bonds have to be just with the carbons. I can't add anything else. So if this carbon has 1 bond here, he'd have to have 3 here to make 4, right? So now this guy has 4 bonds. Now this carbon has 3 on here, so he has to have 1 bond here to make 4. This carbon has 1 bond here, so he has to have 3 here to make 4. And this carbon has 3 on here, 1 here, he has 4. So this is a happy structure. Every carbon has 4 bonds, and it looks like I have some triple bonds in there, which means that this would be an alkyne. I hope you guys can kind of follow the logic I'm using here. This is tough. I'm challenging you. If this is a struggle for you, I would really recommend looking at 18.5 to get some clarity further on this. So your homework today is going to be a little more traditional in that I'm going to ask you to do it on a piece of paper and then text it to me because there's no way I can do this on Google Classroom. So I've got 3 problems for you to do where I want you to tell me if it's an alkane, alkene, or alkyne and draw the actual structure like I just did. And then I would like you to do on page 468, number 6. And there's A through E. That shouldn't take you very long. Tomorrow we have a quiz. Yay! And the quiz is on alkanes, alkenes, and alkynes. If you would like a way to study for that, I would highly recommend looking at the homework we've done thus far. I'm basically going to be pulling questions from the alkyne, alkene, and alkane lessons, I believe from Thursday, Friday, and Monday, and today. And I'm going to be putting those all into sort of one big mishmash. So, best of luck to you. If you have questions or if you're struggling on this, let me know. We can always set up a Zoom meeting and I can help you with your homework. Other than that, good luck. Adios. Love you guys. Bye.